Hello students, today we discuss some numericals based on work power and energy. Here the first numerical for you. A boy pulls a toy with force of 50 Newton through a string which makes an angle of 30° with the horizontal so as to move the toy by a distance of 1 meter horizontally. What is the amount of work done? Solution: as given in question, a boy pulls a toy with force of 50 Newton through a string which makes an angle of 30° with the horizontal. So we can draw simply a figure. Suppose this is a toy and a boy is pulling this toy at an angle theta degree with the horizontal. So as we know, work done is given by scalar product of force and displacement. So here we can write W equals to F as cos theta. Here theta is the angle between force and displacement. Since theta is given, which is 30°, so we can put the values of force and displacement. Force is given in question 50 Newton and displacement is 1 meter, and as we know theta is 30°. So 50 into 1, and as we know cos 30 equals to root 3 by 2. So work done will be 25 root 3 joule. Now next numerical, a block of mass 2 kg slides down an inclined plane of inclination 60°. Then find the work done by force of gravity as the block slides through 1 meter. Solution is as given in question. Here an inclined plane with inclination 60° and a block is sliding on it. So we have to find the work done by force of gravity when the block slides through the 1 meter distance. So this distance will be 1 meter. Initially the block was at the position A, and after traveling distance 1 meter it will be suppose at point B. Here the force of gravity will be downward Fg. Since the displacement is this and force is this, the direction between displacement and force is 30°. So as we know, work done will be F as cos theta. We are finding the work done by force of gravity. So we can write here work done by force of gravity. F will be equal to weight of this block since the mass of block is given 2 kg, so we can write F equals to m into g into s into cos theta. M is given 2 kilogram. G is acceleration due to gravity, and we know G equals to approximately 10 meter per second square. Displacement is given in question 1 meter, and theta is 30 degree, the angle between direction of force and displacement. So we can put here cos 30. By solving this, we get 20 into root 3 by 2. So we get the work done by force of gravity 10 root 3 joule. Now the third numerical. Suppose a hammer of mass 1 kilogram falls freely on a wooden block. If it falls down from a height of 1 meter, how much kinetic energy will it have just before hitting the wooden block? Solution is the initial velocity of the hammer is 0 at the maximum height of 1 meter, which is given in question, above the ground. As it is dropped, it falls down due to the force of gravity, which produces an acceleration of g equals to 9.8 meter per second square. So as we know from the Newton's third law of equation, v square equals to u square plus 2gs. Here given u will be 0 at the maximum height. G is acceleration due to gravity, so it is 9.8 meter per second square. S, which is equal to height of traveling of this hammer, which will be 1 meter. So by putting these values in this equation, we get the final velocity v square equals to u plus 2 into 9.8 into 1. So v square is 19.6. Now the kinetic energy of the hammer just before hitting the wooden block will be given by half mv square. M is given in question 1 kilogram and v square is 19.6. So by solving this, we get kinetic energy is 9.8 joule. Now fourth question. Next question is, a 5 kilogram ball is thrown up with a speed of 10 meter per second. So you have to find first A, find the kinetic energy at the time of throw. Second, you have to find potential energy when it reaches at highest point. Third, C, what is the height to which it rises? D, what is the work done by force of gravity? And E is, what do you interpret from the result of A, B and C. Now, first is solution. The solution of A, as the given in question, a 5 kilogram ball is thrown up with a speed of 10 meter per second. Suppose a ball which is on initially at the ground and it is thrown up with the initial speed 10 meter per second. After reaching at topmost point, its final velocity becomes 0. So, the A, find kinetic energy at the time of throw. As we know, kinetic energy is given by half mv square. As given in question, its initial velocity is 10 meter per second. So here m is 5 kilogram given in question and v is 10 meter per second. So by solving this, we get kinetic energy 250 joule at the time of throw. Now the second is potential energy when it reaches at the highest point. As the ball reaches at its kinetic energy decreases and its potential energy increases. At the topmost point of the motion, the ball comes momentarily at rest. The kinetic energy becomes 0. At this point, the kinetic energy has been converted into potential energy. Therefore, potential energy at the topmost point will be same as kinetic energy of throw by energy conservation, which will be 250 joule. Now, third is, what is the height to which it rises? As we know, as we have calculated, potential energy at the topmost point is 250 joule and the formula for potential energy is mgh equals to 250, h equals to 250 upon m into g. M is given, which is 5 and g is 10. So by solving this, we get the height 5 meter. Now D, what is the work done by force of gravity? As we know, work done will be given by equation F as cos theta. During this motion, the force of gravity will be in direction downward and displacement of ball is in the upward direction. So the angle between force of gravity and displacement is 180 degree. So when we put these values in this equation, force will be the weight of this object. So it is mg as cos theta. M is given, which is 5 kilogram, g is 10, s is 5 as we have calculated in the C point, h is 5 meter and cos theta, theta is 180 degree. As we know, cos 180 equals to -1. So we get the work done by force of gravity will be -250 joule. Now E. In E, we have to interpret from the results of A, B and C. The results are, first, work done by force of gravity is -250 joule, and as we know from work energy theorem, the change in kinetic energy means kinetic energy final minus kinetic energy initial. Kinetic energy final will be 0 at the topmost point where its velocity becomes 0. So we can write here kinetic energy final equals to 0 and kinetic energy initial, which we have calculated in A point, 250 joule. So we get change in kinetic energy is -250 joule. So here we can say work done by force of gravity is equal to change in kinetic energy. And the second point is work done by force of gravity. Again we have minus 250 joule, and when we calculate the change in potential energy, which will be equal to potential energy final minus potential energy initial, as potential energy final at the topmost point is 250 and potential energy at the lowest point is 0, since here height is 0. So we get change in potential energy is 250 joule. So we can show here the work done by force of gravity, which is minus 250 joule, is equal to minus of change in potential energy. Now next question is question number 5. A block of mass 5 kg is given a velocity of 5 meter per second and allowed to move on a rough horizontal surface. Find the work done by the frictional force before it comes to rest. As the solution is, as the block moves on the horizontal rough surface, its kinetic energy decreases and ultimately becomes 0. Where does the kinetic energy go? The kinetic energy is converted into heat energy. What is the force responsible for the conversion of this energy? The frictional force between the block and the surface does negative work, which decreases the kinetic energy. So we can write here work done by friction will be equal to change in kinetic energy means final kinetic energy minus initial kinetic energy. So we can write here final minus initial as initially the block was at rest, so initial kinetic energy will be 0 and final kinetic energy, mass is given in question 5 kg and V is 5 into 5, initial kinetic energy will be 0. So by solving this, we get 125 by 2 joule. Now the next question number 5. Question number 5 is, if the linear momentum of a body is increased by 50%, then kinetic energy of that body will increase by 'Option A is 50%, B is 100%, C is 125%, and D is 25%. The solution is, initially let the linear momentum of body is P. P initial, let this is P, and as given in question, the linear momentum of body is increased by 50%. So the final momentum become 50% T plus 50% of P. So it become 3 by 2 P. Now, as we know, kinetic energy is given by P square by 2 m. Since m is constant, the body is same, so we can write here kinetic energy is proportional to P square. Since m is constant, okay, so and this is the initial kinetic energy, and the final kinetic energy we can write here, it is proportional to Pf square. So kinetic energy, final kinetic energy is proportional to 3 by 2 P whole square, and by solving this we can write also here kinetic energy final is directly proportional to 9 by 4 P square. Suppose this is equation 1 and this is equation number 2. Now dividing equation number 2 by equation number 1, we get kinetic energy final upon kinetic energy initial is proportional to 9 by 4. By subtracting both the sides by 1, we get kinetic energy final upon kinetic energy initial minus 1 equals to 9 by 4 minus 1. By solving this we get change in kinetic energy, means kinetic energy final minus kinetic energy initial upon kinetic energy initial will be, by taking here LCM, 9 minus 4, we get 5 by 4. So the percentage change in kinetic energy will be into 100 equals to 5 by 4 into 100, which will be 125%. So here the option C will be right.